This video was brought to you by the ILC. Hello there, welcome back once again to episode 38. This episode is called Applications of Polynomial Equations. In this episode, I'm going to present a word problem and show you how to write a polynomial equation based on the problem. Let's have a look at it. The problem today is that the edges of the rectangular prism on the right add up to 80 inches, and your goal is to find a polynomial equation to find the prism's volume. I've given you that the two sides that make the base, here and here, are the same, and I'm going to call them x, and that the height is called y. So if I'm going to try to write an equation for the volume, let's start with the definition of volume. We know volume for a three-dimensional box is length times width times height. If we look at this box, we can see that the length of the box on this side is x, and the width on this side of the box is x, and the height is y, so that volume equals x times y. Or in other words, it's equal to x squared times y. Now that's all fine and good, but we have two different variables we're dealing with. And when you want to write a polynomial equation that will help you, usually you want to have just one variable. So our goal here first is going to be to eliminate one of the letters. We'll need to choose which letter we want to eliminate. Now, since y is first power and x is second power, it's going to be a little bit easier for us to try to eliminate y. That's what I would recommend for this problem. Now, here's our strategy. In order to eliminate y, we're going to need a second equation. And in the equation that we are about to write, we need to solve that equation for the one that we're trying to eliminate. We're going to try to solve for y in order to eliminate y over here. To write the second equation, we're going to use the other piece of information that the problem gives us. The edges of the rectangular prism add up to 80 inches. Let's write our second equation now. All right. So whatever this is, this has to add up to 80. Let's have a look at the edges. Look at the bottom layer. The bottom layer has 4 edges. 1, 2, 3, 4, and all of them are x. That's 4x. And if you look at the top layer, it's identical to the bottom layer, giving us an additional 4x. 1, 2, 3, 4. If we look in the middle layer, look at these vertical sides, here, 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 here. Again, there are 4 of them, but all of them are y this time. If we simplify this, we'll end up with 80 equals 4x plus 4x equals 8x plus 4y. Let's now solve this equation for y, because our goal is to eliminate y, so we have to solve for y. I'll rewrite the equation here. First, let's go ahead and move the 8x that's next to the 4y over to the left. We subtract 8x from both sides, so that on the left we'll have 80 minus 8x equals 4y, because the 8x will cancel out. Now to isolate y, we'll have to divide everything by 4. If we do this, we'll have 80 divided by 4, which is 20, minus 8 over 4, which is 2x, equals y, so that our y is the same thing as 20 minus 2x. For our third step, we will replace y with the 20 minus 2x. So where we see y in the volume, we're going to put this 20 minus 2x in its place. So now our volume equation is x squared times 20 minus 2x. If we want to simplify this, all we have to do is multiply the x squared times this binomial. So the volume is equal to x squared times 20, which is 20x squared, and x squared times negative 2x, which is negative 2x to the third power. And there we have it. We have a polynomial equation with only one variable that gives us the volume. We'll expand on this in a later episode. I'll see you there.